Okay, good morning, everybody. So I'm Tony. We've got about 90 minutes to look at the service-based architecture. Paul Waite from Raycastle will just say a few words just to introduce the session, just as everybody else is joining. We've got a few on already. So Paul, if I just hand over to you for a second.
Hello, thank you for joining us and welcome to Raycastle's live training webinar in partnership with FutureNet Asia on the topic of 5G service-based architecture. In this talk, we'll examine the principles of the service-based architecture before looking in more detail at the architecture, network functions, protocol and operation. We also explore the wider context of roaming, 4G interworking and security in order to build a relatively comprehensive picture of how the SPA is set to impact the core of our networks. As I say, it's done in partnership with FutureNet Asia, which I believe is taking place on the 27th of October. Obviously, you're probably all registered to that event, but if you want to know more about Raycastle, you can do so at our website there. Right, next slide, please, Tony. So a brief introduction to Raycastle. We were founded in 1958. We initially specialized in radio and maritime communications. We began training the telecommunications industry during the 1990s and have established ourselves as a leading training organization in the field. We are the preferred partner for many telecoms industry giants, and during the last 60 years, we've trained over 300,000 professionals from all parts of the industry worldwide. We have an extensive portfolio of courses covering all the major technologies. We use a variety of delivery formats from classroom to live virtual classroom and on-demand distance learning. As you'll see here, our expertise and focus really stretches from all network technologies, from DSM through to 5G, from the core network through to the radio access network and everything in between. We're also got quite a bit of content looking at connected innovation space, including IoT, M2M and smart cities. Our customers span different industry sectors, including network operators, vendors, integrators, and service providers, plus the transport industry, defense industry, security, government agencies, and regulatory bodies. You'll see a few highlights there below. Now, this webinar will be delivered by Tony Wakefield. Tony is a highly experienced trainer, both technical and in telecoms business, as well as a competency development specialist, having worked with a diverse range an extensive base of companies worldwide. He has spoken at global conferences and has extensive experience in facilitating programs on 5G and the wider aspects of telecoms and connected innovation. As Tony said, this presentation will last about 90 minutes, after which there'll be a live Q&A. If you have any questions, please post them in the chat box and we'll answer them at the end of the session. If you could please ensure you have your microphone muted throughout, then that'll make it a little bit easier. So I'll now hand over to Tony for the main presentation. Tony, over to you.
Okay, thanks, Paul. And once again, just to say welcome, everybody. So just start my video just to say that I'm here and I'm a real person. Don't really expect you guys to pop your videos on. If you want to ask questions, probably the easiest way is in the chat box. There's something really burning, then perhaps we can switch on your microphone. But we've got 90 minutes maximum. So quite a lot to get through. So I want to sort of keep the flow going, but your questions are very definitely welcome. But also you see at the bottom of the slide, there is my email address. So twakefield@raycastle.com. And if you've got anything which is more in depth and you want a bit of a discussion on it, then please use the email address after the event and we can try and get you an answer. Okay, so I think what I'll do is I think I will just stop my video and then pop it back on again at the end, if that's okay. Just save a little bit of bandwidth. Okay, so that's me. So I'm Tony. So I've been doing this, delivering training for 25 years, but I am ex-BT. I've had a few other jobs, not least sort of heading up a telecoms training organization where we truly delivered courses worldwide. So wherever you are in the world, I've been nearby, not necessarily to your country, but nearby, I'm sure. Okay, so just a preamble, really, just looking at 5G. So 5G develops ideas on a lot of different things, but when we first started looking at 5G as an industry, we had to decide what the scope was. And the scope really is driven by the business, by the industry itself. So 5G itself started off by looking at value creation within the industry. So what is it that companies in the industry now and in the future will be doing to build value or help their customers to build value in the coming years? So first of all, we looked at value creation. We looked at business models and how they might change, not least some of it sort of centered on spectrum and things like that. Because obviously, frequency spectrum is a very valuable resource. And up until 5G came along, really, from a cellular perspective, we'd only been using a certain amount of it, mainly because we optimized for sort of big cells, decent coverage and things like that. But with 5G, we could look a little bit differently because the industry had moved on in the previous sort of 10 or 15 years. But what these two really did was throw up these use cases, and the use cases are a whole sort of topic in their own right. But the use cases, whether it's the 3GPP version of the use cases, so that's third generation partnership project, the people who standardize a lot of the technologies for cellular. So whether it's their value of the use cases or whether it's another big industry bodies version of the use cases, it doesn't matter. The use cases were never meant to be exhaustive. They were just meant to give us a bit of a heads up or a little bit of guidance on what we're trying to develop as a system to support. So which use cases do we need to support? And we got a really good idea of the use cases, and these will pop up again as we go through the presentation today. Use cases you might have heard of: enhanced mobile broadband and massive IoT and ultra reliable and low latency communications. You might have heard of those. They are the use case categories. So what we did was come up with lots of different example use cases, and then we categorized them. So we got a sense of the sort of performance objectives that we needed to support in 5G without it being too complex. And then we designed the system around that. So the use cases, the business models, the value creation really underpin all the sort of developments, and not least the way in which the core network, the service-based architecture, has been developed. So the 5G technology essentially better supports existing broadband business models, so delivering all that data to all those consumers or business users, all that huge amounts of connectivity that they need. So it provides us with, through various mechanisms, means of cost control and efficiency. But also it provides us with support for these new use cases. So a very wide range of service and deployment scenarios, new capabilities and frameworks, and agility and business processes. The technology itself actively supports things like agility. So where a business can much more quickly support a request from one of their customers. So the speed at which we can actually get new services, new connectivity, new support into our network. And that's at the heart of the service-based architecture, trying to get that sort of agility into the network. So that's the sort of preamble. But what we're going to look at in the 90 minutes is, first of all, the architecture principles. Then we'll look at the 5G core without really talking too much about the service-based architecture at this stage, because we're going to introduce that next. So this will be sort of looking at the 5G core in the same way that we looked at perhaps the 4G core or the 3G core or the 2G core. So we'll get a sense of what we're trying to do in terms of the functional elements. Then we'll look at how we actually configure it, or how we plan to deploy it in 5G, so the service-based architecture itself. We'll then spend a little bit of time talking about service-based architecture in support of the roaming scenario. So very often we sort of see this as a worst-case scenario because it is more complex than if you've got a customer who is using services in the home network. The roaming scenario means inevitably two networks collaborating and cooperating. So that will be a good thing for us to look at, just because it allows us to look at the more complex cases. We'll also look at interworking for the same reasons. And there's something called slicing. Now, slicing and use cases, they're not the same thing, but they're sort of two sides of the same coin in some ways. I think people argue against that, and that's perfectly valid, but I'm just trying to sort of simplify it here. But if you as a telecoms operator develop a really good set of services for a big car manufacturer, it would be a great idea to capture the configurations, capture the work that you've done, document it, not just the technical bits, not just the connectivity, not just the configuration on the network, but also the business decisions behind it as well, and document it so that you can take that whole package and resell it to another car manufacturer. And effectively the technical bits of that, the configurations become a slice. Now, they aren't use cases, but wrapped up in those slices will be the use cases, will be the actual connectivity specifics themselves. So we'll talk about slicing and how the service-based architecture really can be used to support all of these concepts. We'll then define something called network function services, because that's at the heart of what the service-based architecture is. It's actually each and every network function will provide a range of services for the other network functions. Now, it's not services as in services for the end customers. This is sort of network-based services for the other network functions. So we will explore that a little bit. We'll then look at the protocols and how we actually format the information. We'll then look at the service-based architecture and operation so that we can start pulling things together, start making real sense of it in the context of the system itself. And then we'll look at security and the service-based architecture as well. So we're now down to, where are we? 80 minutes. So we've got quite a lot to cover. As I said, if you've got questions, pop them in the chat box. We won't be taking a break because it's, we'll just eat into the time. So an hour 30 is quite awkward as a webinar in terms of time, just slightly too long for comfort, but not long enough for a break. Okay, so the architecture principles. So key technical features of 5G, based on the work that we did with the value creation and the business models and the use cases, that gave us direction as to what we wanted to try and achieve with the actual network itself, so the architecture. So we came up with the principles, and the principles really gave us the absolute foundation for the further development of the system. So first of all, from a radio point of view, it's based on orthogonal frequency division multiple access, OFDMA. Now, if you're not a radio engineer, you might have heard the term, but you won't necessarily understand the details, and you don't really need to. All we need to think about really is that it's the same fundamental technology as 4G, which is great because it's still one of the most efficient radio techniques there is, certainly the most efficient wide-scale available radio techniques there is. And in 4G, we optimized it for really what was happening sort of 15 years ago, which is that network operators still had, on average, quite large cells. We had to think about the worst case scenario from a radio perspective, which is trying to provide radio links within cities and towns. So OFDMA was configured in a certain way. Now, what we've done in 5G is we've just brought a lot more flexibility into it, so we can dynamically reconfigure it for small cells, big cells, lower latency, cities, rural areas. So we can optimize it across a much wider scope of deployment scenarios. It also means, because we're flexible with this, we can use higher radio frequencies, we can use really smart antenna arrays, which bring a lot of efficiency to the radio. But also, there's lots of customers out there with 4G devices. It's the same underlying technology, and where 4G has been optimized really well for perhaps bigger cells in urban areas, we've still got to provide coverage for larger cells in urban areas. So there you go. Why not work with LTE? And 5G works really well with LTE. So both from a purely radio perspective, but also we've made sure that the system itself works really well. And that's got some real implications later on for the service-based architecture. So we're going to work really well, really nice with LTE, to the extent that people talk about non-standalone 5G, where devices need to connect to 4G first, before the 4G system decides whether 5G connectivity should be given. And then later on, we're just starting to see this starting to roll out in some networks now. Later on, standalone 5G, where the device itself can connect directly to 5G right from the off. In a similar way to working with LTE, it makes sense that network operators also want 5G to work much more closely with Wi-Fi. Even now, smartphones, most of the data, something like 80% of the data on smartphones comes over Wi-Fi, not over 4G, not over 5G. So Wi-Fi interworking is built into the whole system as well. To simplify things, there's no support for 2G or 3G. Now, that doesn't mean to say that if you buy a 5G phone, you can't use it on a 3G or 2G network. It just means that when we start looking at the system, and for example, the service-based architecture, there's no real provision for interworking with 3G or 2G. But don't forget, 5G will work with 4G, and 4G itself will then work with 3G and 2G. So if you buy a handset, it's still going to work on 3G and 2G. But in terms of the system, in terms of the sort of procedures that we're going to look at, we don't have to worry too much about 2G or 3G. So then that leaves these three, and these three now are very, very closely aligned with the service-based architecture. So what we want to do is we want to move away from operators having to buy a fully configured piece of hardware which will do a certain task in the network. So you go to one of the big vendors and you're looking for a database. Well, you've got to buy that database because that database on that platform will give us all the telecom specific functionality. And that's been really costly. In fact, in different parts of the network, we moved away from that decades ago. I can think of SS7, signaling system number 7, if you're familiar with it. If you're not, it doesn't matter. It's just one of the sort of core network protocols. It's a very big protocol, very modular protocol. But what we did in the 70s and 80s was we came up with a number of different sort of individual message sets for different things in the network, and then they could be programmed onto SS7 nodes. Now, not in a particular, not in a way that fits with our current notion of this virtualization theme, but certainly in terms of the principles, it was there. So network function virtualization is about being able to buy perhaps best of breed, commercial off-the-shelf hardware and be able to program that hardware to give us the functions that we need in that particular place at that particular time. So network function virtualization, absolutely where the IP world has been heading for the last decade and more, and certainly where we've been trying to drag telecoms kicking and screaming over the last 5 to 8 years. It's been a difficult task for us, but the service-based architecture, to me, represents a much easier route to network function virtualization. As part of that, we also need to look at the routes of IP packets through the network. So going hand in hand with network function virtualization is software-defined networking. And if we get those two right, I said earlier, network slicing is all about getting the right functionality in the right place to support our customers and get the agility in place to better support those services. So hopefully you're thinking, well, yeah, if you've got NFV and SDN in the network, supporting these slices in a much more agile way, supporting these service sets, if you like, as required, will be simpler eventually. So 5G, again, just to reiterate, the key technical features of 5G include this massive move towards virtualization because it supports a lot of the things we were talking about earlier in terms of value creation and business models. So these three things really key for us in terms of service-based architecture. And again, if we sort of look at some of the big themes in the network, we've got movement of processing. Where does the processing actually sit? And for various reasons, the core network processing or processing that has traditionally been done in the core increasingly is being distributed, either because moving information to and from the core takes time. So for lower latency type services, we want to offload, or we want to sort of move that down towards the customer. Or it might be that for efficiency's sake, in terms of putting cells in place, we just want to keep the actual cell site to an absolute minimum, but move the processing back into the core. So just two big examples, really. So a really good example of the left-hand principle is perhaps vehicle roadside units. If we're trying to support connected vehicles or autonomous type vehicles, to keep the latency down, to keep the reliability up, then perhaps we put the processing at the junction itself rather than in the core of the telecoms network. Or maybe to offload the core content delivery, we move content down towards the equipment room of an airport rather than trying to serve it from the core. An example on the right-hand side, just for control and capacity architectures, if we've got a lot of cells or a lot of base stations in a certain area, so campuses, airports, business, residential, leisure, perhaps having a single sort of master cell and then that parenting several smaller secondary cells, you're sort of thinking, well, actually that master cell is already sort of acting for the secondary cells as if it's sort of like an old style base station controller or radio network controller. It's not the same functionality, but the same sort of principles. So anyway, so we want to sort of be much more flexible in where we put the processing. And as soon as we start thinking flexibility, what we don't really want to do is move the processing and that's it, decision made. What we really want is a really flexible architecture where perhaps that processing can be later on reconfigured and moved elsewhere, depending on time of day, capacity requirements, security requirements, latency requirements, whatever the requirement is. We said we want to support network slicing. So network slicing is represented here, looking at the user equipment all the way through to the external data network, through the radio access network and the core. And what we're saying is if we configure things within a common underlying infrastructure, then we can support perhaps enhanced mobile broadband or ultra reliable and low latency communications or massive IoT or vehicles. Now these already you might be saying, well, actually, these are the use cases, Tony, they're not slices. Now, I did say there's a big tie-up, and actually the initial slice identifiers, so the slice identifiers have been aligned with the use case categories as well. So within the specifications, there's absolute alignment in terms of the identifiers with the actual use case categories. But again, we need to be able to support perhaps these slice types for different customers, and each customer might have their own requirement in terms of capacity or time of day use or reliability or security. So even by having a slice, we can't absolutely nail where we want the functionality. A slice for one customer might be completely different to the same slice for another customer. But what this all leads to, so what these three things really lead to is this. We need the new network, the new core network, to be aligned with network function virtualization, because it's network function virtualization, this whole notion of being able to buy commercial off the shelf. So hopefully these things, kept bang up to date, maximum processing power, being upgraded as necessary, and then being programmed, or make sure they've got the right software to provide the right network functionality for that particular set of customers at that particular time. That's what we're looking for. So we could also look at the business side of things. So it's off-the-shelf hardware. So the network remains hopefully bang up to date as we upgrade the hardware. Independent software vendors, so potentially we can start choosing other vendors other than the big telecoms vendors that we have been using largely up until this point. Automatic remote installation of those network functions on those platforms and ease of upgrades. We get lots of benefits, you know, those 4 there amongst others. But there's 2 parts to this. One is network function virtualization itself. So actually making sure that once the software is on the right platform, then everything works to give us the right procedures. Remember, 2G, 3G, 4G, 5G have got certain ways of working. We need to think about procedures for connectivity, procedures for mobility, procedures for security, as well as a whole host of other things. So what we're saying is, once the actual software is on the platform, then we need it to all work correctly. So network function virtualization itself is taken care of by the service-based architecture. The second part of this whole thing is management and orchestration. So what software needs to sit on what platforms? So what functions need to be spun up on which platforms? So that decision-making process based on, you know, capacity, use, time of day, reliability, low latency, whatever it is, that whole decision-making process is management and orchestration. Now, for telecoms operators, that's been the most difficult part of the whole equation. So what I'm saying is that service-based architecture really still deals with the first bit, the actual mechanics of, you know, the operation once we've chosen which platforms are going to sort of host the functions. But the management and orchestration is still something which needs to be developed in parallel. So plenty of sort of references to management and orchestration in the specifications, but the service-based architecture itself, for me, is much clearer if you just consider it as the mechanics of the actual operation itself. Hope that's clear. Okay, so let's move on and look at the actual 5G core itself. So the 5G core, really stylized view this. We're missing a lot of network functions on purpose because we just want to keep it really simple. So we're just showing one network function of each type. So what we're saying is in the solid red there, we've got the path for the customer IP packets. So the actual user traffic. Now that doesn't have to be IP in 5G. It can be Ethernet packets. It can also be unstructured data. But the whole process of putting those paths in place is really the purpose of the 5G core. That's what we're trying to do. We're trying to connect the end device to the servers or whatever it is that we want to connect it to. So what have we got? So we've got a whole number of different network functions. So in 4G, we've got an MME, so mobility management entity. In 5G, we've got something called the AMF, the access and mobility management function. So that is sort of the point of contact for the base stations, which sit down here. So the base stations in 5G are called GNOBs, and they will work with the AMF. So anything to do with radio, the UE will talk to the base station. Anything to do with services and connectivity and mobility, then the UE will talk through the base station to the AMF. Actually, in 5G, anything to do with connectivity, the device will talk through the base station, through the AMF, to the session management function. So the AMF and the SMF are going to have some way of talking to each other. Of course they do. And then the SMF will have under its control one or more user plane functions. Now, if you're looking for parallels with 4G, then the SMF and the user plane function together are like the packet gateway. So there you go, packet gateway user, packet gateway control. So those two together are a bit like the packet gateway. Now in 5G, we don't have a serving gateway. if we need, if I'm roaming, if I'm on holiday in Dubai or somewhere, then there could well be a second SMF and user plane function with me in Dubai, but there isn't a separate serving gateway. It's another user plane function, so slightly different to 4G. Now, there's a really big principle, which I'll go through later on. The AMF, whatever we are supporting for the customer, so whatever slices we are trying to support for the customer, then that has got to be provided by the base station that they're using and a single AMF. So to make sure we've got the right AMF, the network slice selection function can help us. Now, remember, this is a function. So we're showing it as a separate icon here, but in reality, that could be part of the platform here. It could be anywhere. It could be in the Amazon Web Service. It's a function. We're just showing it as a function. So we've got the AMF working with the base stations. We've got the SMF working with the user plane functions. And these two can talk to each other. In terms of user data, in 5G, well, we used to have the home location register. We used to have the home subscriber server. You do see that in many networks still. In 5G, we've got the unified data management function, the UDM. So this is the customer database, subscription database. Traditionally, behind there, we've had the authentication center. That's still there. So that still generates security parameters. But in 5G, we've got another security function, which is this authentication server function, which just sits in the home network. So when I'm in Dubai, if the Etisalat network in Dubai wants to authenticate me, it can do so, but it has to send a request via the authentication server function back in the home network. So it's just an additional sort of security feature. And then finally, the one last thing, there's the PCF, the policy and charging function. It's not something that's new in 5G. We've had PCFs or PCRFs, policy and charging rules function, in 4G, but in 5G it's called the PCF, and it's the PCF that has the big picture in terms of the rules, in terms of connectivity, in terms of quality service, and in terms of charging and things like that. So that's the 5G core network. For those of you who work in cellular systems, you might already know this, or you might see a lot of parallels to what we've seen previously in 4G, especially if in 4G you are familiar with the very latest specifications. So release 14, I think it was, where we introduced something called control and user plane separation, CUPS, in 4G. So CUPS in 4G looks very much like this, where we separate out these two parts of the packet gateway. So in 4G, we've already separated these out. In 5G, we give them a different name. Okay, so that's a run around of the core network, primarily, not so we understand everything about those network functions, but just so we get a feel for what's going on, because we also need to then look at the interfaces. Now, there are still these, I'm going to try not to call them interfaces. Let's just call them reference points, because interfaces sort of imply that you've got protocols, i.e. rules, sets of rules for connecting different things together. So we are going to have rules for connecting all those different things together, but actually it's going to be one big set of rules. So whereas previously in different systems, we've had individual sets of rules for each of the reference points, i.e. individual interfaces for each of the reference points. In 5G, we've still got the reference points, but it's sort of one big set of rules. So one big set of rules. And that's what the service-based architecture is. So we'll look at how we're going to exchange information between all these different network functions. So these are the same network functions that we saw in the last diagram. Just bear in mind that when the AMF, so don't forget that's a bit like the MME in 4G, when the AMF talks to a base station, that's going to have its own set of rules. So that's still going to sort of be a bit like the old style protocols. So anything which is talking to a user plane function down here, so whether it's the AMF talking to the base station or the SMF talking to the user plane function, they're still going to have their own protocols. But this stuff, so any control function to control function reference point will use the service-based architecture. Okay, so how are we doing so far, guys? Are we, is the pace okay? Just in the first question, go through there. Okay, just Shakilo just asking, oh, great, thanks, Jeremy. Yeah, Shakilo just asking about deep packet inspection and things like that. Yeah, it's exactly the same way. So you're going to see that we're going to generate packet filters for the user plane function. You'll see that a little bit later on. So the SMF, so the PCF can talk to the SMF about exactly what it is that we're looking for in terms of quality of service and things like that. And packet filters will be dropped into the user plane function, or will activate certain packet filters for the user plane function for certain packets arriving. So we can look at the packets, we can make a decision, and we can send it onto the right customer through the tunnels. So it's very similar. If it's other sort of analysis, you'll see later on in the annex, I've got some additional slides which just show that there is sort of network data analytics function, which will give us a sense of what's happening on the network. So that's a properly defined function in 5G. But for just normal sort of deep packet inspection, then it would be at the user plane function, just in the same way that it was at the PDN gateway. Okay, so just to get it out of the way, because it's not really part of the service-based architecture, the user plane protocol stack. If you're not into protocol stack, you can close your eyes. If you are, I'll just give you a really quick rundown. So application level is end-to-end. Then we're going to have our PDU. So if we are moving IP packets through to the user, we move it from the external network to the mobile operator, for example. So if we use the example of a mobile operator using 5G in the network, so we move it to the mobile operator, who will then use a system of tunnels. So the GPS tunneling protocol is still there in 5G. So we tunnel it down towards the customer. We might have split the base station, so it gets a bit more complex down here, but essentially we just tunnel it down to the user. So so we could be using IP packets to facilitate the sort of end-to-end connection, certainly the networking layer there. We would then be using IP to give us the tunnels as well through the system. Right, I'll keep that really short, because that is the way in which we use the way in which we are deploying the IP. The way in which we're deploying the user plane. Remember, we could be moving IP, or we could be moving Ethernet, or we could be moving unstructured data. But essentially, it's a very similar sort of configuration to what we see in 4G. There are some slight changes. There's an additional header, for example, in GTP, simply because we need it, because we're moving away from EPS bearers to something called QoS flows in terms of the actual quality of service provision and quality of service management. So we need to be able to denote exactly which QoS flows we're talking about within the GTP headers. But apart from that, very, very similar to what we've seen in the 4G. Okay, so let's sort of move on and just look at the core network control protocol. So this was all about moving the user packets. So the user plane traffic. This is about the control messaging. So just by comparison, second generation systems, if we just use the update location message, I'll call it message, just for simplicity. So within the core network of all these cellular systems, we need to do things like updating the location of a device. So if we just take that message or that operation and say, okay, in 2G, the way in which we implemented that was using a message, a specific set of messages actually within the mobile application part of SS7. We had a couple of additional protocols within the stack just to manage the interaction between the two network elements, and I will call them network elements in 2G. So we had something to manage the transactions, so the transaction capability application part, and then we had something to manage the addressing, simply because SS7 wasn't up to sort of messaging and exchanging information between different networks. So we had something called signaling connection control part. So we control the connection. And then we've got the message transfer part of SS7 at the lower layer there. So that's 2G. That was based on a system that we'd already brought into the fixed network, but heavily modified for mobile with a whole new set of messages. When we move to 3G, we still use that same set of messages. We still sort of manage the end-to-end transactions using transaction capabilities, and we still sort of manage the end-to-end, we still manage the connection between those two endpoints using SCCP, signaling connection control part. But this time, instead of using SS7's own sort of packet switched lower layer network, we use signaling transport, and what that does, it just allows us to sort of map between SS7 upper layers and IP down at the bottom. So we're starting to move towards IP even with 3G. Now, when 4G came along, we simply took a lot of the logic that was already in the mobile application part, and we sort of mapped it into diameter on the specific interfaces, on the specific reference points. And then we managed the end-to-end connections, the actual connectivity, using an IP-based protocol, stream control transmission protocol, and we carried that over IP. Right, so then we come to 5G. So with 5G, we've taken much of the same logic again, but this time we're going to format it using JavaScript object notation, so JSON on the specific reference points again. This time, we're going to exchange the information end-to-end, not using TCAP or diameter. It's going to be HTTP2, Hypertext Transfer Protocol 2, HTTP2. So much more on that later on. We're also then going to facilitate end-to-end connectivity using TCP as well. So it looks like there's a bit of duplication there. So that's been a bit of a bone of contention in the industry. Do we need both of those? The answer is long-term, probably not. So I'll say more about that later on, but TCP goes with it, and then over IP again. So that's the movement, really. That's how we've taken the core network control, which is what the service-based architecture is absolutely all about. So service-based architecture is all about this. And this is what it looks like in 5G. And there's some really good reasons for it, because that is aligned with virtualization and gives us the flexibility we need. So that's the mechanism for the service-based architecture, and we're going to build it around that. So let's have a look at the service-based architecture then. Excuse me. So here it is. This is what it looks like. So do you remember those reference points we looked at? They're still there. It's just that's a different view of the network. But what we've done here is we've just brought the different network functions together. We've used probably a simpler way of representing the actual service-based architecture than we had previously using those reference points. And the key thing is that each one of these points now is an API. So network function services defined on service-based interfaces. So these are service-based interfaces which are going to be defined as an API, which we'll talk about later on. So in terms of the way in which they are implemented, it's using signaling messages which are defined on the reference points. Signaling messages, there you go, signaling messages defined on the reference point. So the JSON information together with information within HTTP2 headers being used to define these service-based interfaces. So you've got different service-based interfaces for the different network functions. Now, remember, we're going to be able to sort of spin up the software on different hardware. But once that software is spun up on the hardware, then each one of these network functions will provide the set of services there defined for it as the network function in accordance with the API. So the big question is, well, okay, how do we know, if the AMF wants to speak to the AMF, how does it know where the AMF is? Well, that's where these extra things come in, actually. So we haven't seen these before. Network repository function, which I'll talk a lot about, network exposure function, and the application function there. But the main one is the network repository function just there. Sorry, just give me a second. Okay, so that's the network repository function just there. Okay, so this is what happens when we spin up a new function on a platform somewhere in our network. Of course, we need other network functions to be able to find it and to use it. So when that network function is being spun up, first thing it will do is it will tell the network repository function. So the network repository function is just going to keep a bang up to date list of all the network functions on the network. And what information does it have? Well, here we show the registering network function, telling the network repository function, first of all, about itself. So what is its network function ID? So unique identifier. Network function type. So this could be an AMF. Status, which slices it supports. So you can't make head or tail of that unless you've come across this acronym, but that's a single network slice selection assistance information, plural. So single network slice selection assistance informations. So which slices is this function actually supporting? What's its current IP address and domain name, capacity, load, and a few other things. Now, actually, even at this point, we need to start using the right procedures. So we start in this particular message exchange, we are showing the right conventions in terms of the messages. So N just denotes that this is going to be one of the service-based architecture messages. So we are sending the message, or let me put it this way, we want to use the service of the network repository function, the NRF. So NRF, I want to use your network function management, network function register service. So the service is network function management, network function register. So that's the service. The service in this case belongs to the NRF, and it's a request. And the NRF will say, yeah, thanks very much. Here you go. Let me just send back your network function profile back to you to check that we've got it okay. And here's a heartbeat timer. So every so often, every whatever it is, a few minutes, just do an update. So the NRF can tell any registering network function to do an update. And later on, we can do that update and we can get the response. So that's how the network functions. That's how the network keeps the NRF up to date on what functions there are and where they are. What is the IP address of these current network functions? And of course, in the background, we've got that management and orchestration making decisions on what's being run up and where, etc. So that's the NRF. So here you go. So this is a NRF. We're showing the NRF there on the service-based architecture. So sitting just there, and just to absolutely nail this, the NRF now provides a lookup service. So the NRF, because it's got all the details of what's available, it can be used as a lookup service by the other network functions. So enabling the relevant network function services in the core network to be identified and selected because they are registered with the NRF. The network function service discovery process is used for this purpose. So that's a specific service or set of services that it provides. And it's a key feature of the service-based architecture. So it enables that network function virtualization, absolutely key to the whole thing. Okay, so that's the NRF in terms of holding information and being prepared to make it available. So how does perhaps the AMF here find out which SMF to use to support a certain service? So this is now the network function service discovery service. So this is perhaps a little bit later on, an AMF wants to find out about an AMF, so it can send a message, a request to the NRF. So network repository function, I want to use your network function discover service. And this is a request for that. So this is perhaps the AMF giving the NRF information about the service it wants to access. Which AMF service does it need? The fact that it's looking for perhaps an SMF, a session management function, within a target network, a target public land mobile network. And perhaps this is a TISLAT. So perhaps a TISLAT now would name itself as a operator. So using the Dubai network code and the country code, mobile country code, as well as slices that it wants support for. So already the NRF can be thinking, so this particular connection, whatever the user is requesting from the AMF, they're requesting support for a certain slice, the NRF can actually start making decisions about ensuring that we connect the right SMF, the right session management function, and therefore the right user plane function for the customer. So all of that can be requested from the NRF, and the NRF can come back and say, yep, here you go, valid for the next X number of seconds. You've got these choices, and these choices hopefully should satisfy what you're looking for. So that's network discovery. So all we've really said is, look, the NRF, we've added, there's the service-based architecture. We know the NRF is a massive part of that. So the registering function, all the functions on the network register as they are spun up on the different servers. And then the NRF holds the information and can be used as a lookup service. And then we're showing the service discovery here. Yeah, Prabhat, let's do a little bit on the security later on. So the answer is yes. So either we're going to use transport layer security with the certificates that are needed to facilitate that on the service-based architecture, or there's got to be some of the mechanism in place. The standards are very woolly because they want to give operators flexibility on it. But certainly if it's between operators, between two operators, and you'll see a little bit later on, we've got a whole new function, the security edge protection proxy to provide that level of authentication. So I'll come back to that later on. Yeah, so Yusuf, who's going to build the API? Well, that's the whole point, actually. So it's an API, it's a standard API. So it's already in the 3GPP standards. It's ready to be implemented. So in terms of software, we've sort of divorced that from the actual vendors. It could be any software vendor that will make this available for the operator. And of course, just to add to that, we are going to be using HTTP2, so the standard mechanisms to make all of this work, which we'll look at a little bit later on. Okay, now the network exposure function as well is quite important. So this just goes back to your question, really, Prabhat. You're talking about security. We don't want any old network function being able to access these service-based interfaces. So the network exposure function can be used to provide exposure of information in a very controlled way to application functions. Now, application functions, I'll not explain what they are. There's something that's been around for quite a few years now, but probably the one that we know most, if we're involved in the core network, might be the proxy call session control function, so the IMS, effectively. So the IMS, from the point of view of the service-based architecture, the IMS will be an application function, specifically the piece, the proxy call session control function, perhaps. So the network exposure function can make sure that information is exposed in a very controlled and secure way. So it provides exposure to application functions, exposure from application functions, and would also allow, for example, translation to and from the application function and internal 3GPP network functions, and also perhaps movement into the network of these packet filters. So the network exposure function can pass those on to the SMF. So the SMF can then move them into the user plane function. So we can check the packet filters against incoming, perhaps IP packets, to decide where we send them and how we handle those packets. So the packet filters. So I'm just aware that I'm sort of skating over that. We've got a whole course which sort of looks at that sort of thing in detail. So we've got a whole course which looks at that. Those sort of techniques in detail, but there's quite a lot to it. But what I'm saying is that we can actually take external optional. We can take external packet filters and make them apply them to the user plane traffic. A lot of details in technical specification 29.522. If you're looking for standardized sort of northbound exchanges here, that's been worked on in 5G. So that's called CAP-IF, Common API Framework, CAP-IF. So that might be something to look at as well. Excuse me. Okay, so let's move on. So already we've been going just about an hour, so we will get there, promise. All right, so let's have a look at the service-based architecture in support of roaming, interworking, and slicing. So this would be there's my UE, there's my device, my smartphone, and perhaps I'm in Dubai, and perhaps this is back in the UK, and we're trying to connect my smartphone, so it's got a path, IP path, for me to access the latest Netflix from the UK, operator that I'm with. So what it means is that Etisalat, if I'm using Etisalat or doing in Dubai, we're going to have lots of exchanges, lots of information passed backwards and forwards back to the UK operator here. So we will facilitate that, we'll help that by these security edge protection proxies. So they've got the right sort of security certificates in place, etc., to make sure that we've got a secure exchange of information between operators. And the network repository functions will now work in tandem. So if the AMF wants to talk to the SMF in the UK, it can do it. It will send a request to its own NRF to say, hey, I want to get hold of an SMF with this service in this network. Can you help? And the NRF will say, well, I can't, but I can forward your message on to the UK, who should be able to help, who should be able to give us details of one of their SMFs. So can you see how the lookup table, the lookup procedure sort of works, in this case, in a two-step process. So it works like this. You got a network repository function. I want to use your network function discovery, network function discover service. This is a request. I'm trying to get hold of a SMF to give me these services. In the UK operator, so here's the number for the UK operator. I'm Etisalat, and we want to support this slice. And the NRF in the Etisalat network will say, well, I can't help you, but I can just send that on to the UK NRF. And then the NRF will just simply forward that back through the NRF in Dubai down to the AMF. So fairly simple. A couple of other ways of sort of interworking between networks. We just showed two 5G networks interworking together in the way they should. Another thing to consider is that, you know, for a considerable period of time, we're going to have 5G core networks and 4G core networks working in tandem, in parallel. And although we can sort of start taking 4G core networks towards 5G by starting to adopt some of the principles, sometimes we're just going to say, okay, well, we've got a 4G network there, we've got a 5G network here. The two have got to work together, just pure interworking. And actually, it's more straightforward than we think, because you can see here we've got two network functions. One is the 5G user plane function, and the other is the 5G session management function. Do you remember I said right at the beginning of the talk that those two together look like a packet gateway? So there you go, packet gateway user plane, packet gateway control. So those two together can talk to a serving gateway using the legacy 4G protocols. So those two can just use 4G to talk to the legacy serving gateway, and the serving gateway will be none the wiser. It will just think that it's talking to a packet gateway. So actually, that's quite straightforward. And then fortunately, all the other sort of 4G functions, like the PCRF, look very much like 5G functions, the PCF. The HSS from 4G looks like the UDM. So it's simpler than we think. I'm not going to say it's simple, but it's probably simpler than it could have been, for sure. Oh, that's a really good question. So how will a visited NRF discover a home NRF? So again, if we have a quick discussion of that later on when we look at the security, because the two core networks will need to authenticate each other, we'll need to set up tunnels between those two core networks, but essentially it's on standard addressing, the public LAN mobile network address. Probably a little bit more to it than I can go into in this talk, but probably, I don't know if did you do any work on the signaling connection control part of SS7, where, you know, traditionally we've sort of had perhaps a single HLR in the network, but it's been distributed. But all the legwork for SSM was done at SCCP, which looked at the incoming request and decided exactly which platform to send that incoming message to. So it was a sort of single identifier, but then SCCP itself decided exactly where to send it. So presumably we're going to have similar sort of mechanisms. I think that's one of the areas where perhaps there's a bit of flexibility. But great question, actually. Okay, so I've just sort of talked about 4G and 5G looking quite similar, which is great for pure interworking. But actually, the traditional vendors have actually gone one step further. Now, this is really interesting, because remember, what we want to do is we want to give ourselves flexibility to get away from the traditional vendors by perhaps, you know, buying bang up to date commercial off the shelf computing equipment and then programming it with the service-based interfaces. But this is Ericsson saying, actually, well, we can save you a whole lot of trouble here. What we can do is we've come up with the dual mode 5G cloud core. So what Ericsson have done is they've said, okay, we can take the principles of the service-based architecture, we can take the principles of HTTP2 information exchange, and we can simply place 5G, so 5G in yellow, together with the equivalent 4G equivalent network functions within a sort of bigger box. So if you want to spend money on your 4G cord now, but you want to future-proof it for 5G, this could well be the solution. You can actually put more capacity into your 4G core, and then when ready, move this functionality over to 5G when you're ready. So it sort of future-proofs the system, but also allows us to gain the benefits of the things we found important in the first part of this talk, which is the flexibility and the ability to make decisions on where these functions sit in the network for reasons of whatever it is: capacity, security, latency, etc. And then slicing and the service-based architecture. Slicing itself is a whole separate topic, but just to give us a flavor, what we're saying is, in terms of the access, the base station, the AMF, they will serve all of the slices that the device wants to gain access to. The network slice selection function provides an AMF selection service. So whatever the slices are, we need to make sure that the AMF can support all of those slices that we agree to as a network, as an operator. And then slices can in time be differentiated within the access, within the radio. So different slices will have different support mechanisms. In terms of connectivity though, once the device starts asking for specific connectivity, then that can be slice specific. So although we've got the same AMF, remember the AMF could, depending on the slice that's been requested and the connectivity that's been requested by the device, the AMF could use a different SMF and therefore a different user plane function to provide that connectivity. So a really good example here is where perhaps you got an SMF which is providing just general internet access, but suddenly if you want to access Netflix, and Netflix have cached a lot of their content down in the airport equipment room, then quite clearly, the SMF might be slightly different for that. It doesn't have to be, but certainly the user plane function would be. But the fact that we've got a SMF which can make decisions, as long as we get the right SMF, as long as we've got an SMF which can make decisions based on user data, based on the subscription data, then the actual connectivity can be slice specific. Now again, I'm just wary that I'm going to give a very satisfactory explanation there. It would take a long time to do that, but if you just accept that in the access, we've got to have a device would need to use the same G-node B and AMF, so same base station and AMF. In terms of connectivity, it is slice specific, or can be slice specific. And the information itself, so the device can request support for up to 8 slices when it first connects. Of course, when it then establishes a connection for one of those slices, it's really asking for connectivity for one of those slices, but it can have connectivity for more than one at a time. The UDM, so remember that's the Unified Data Management Function. So that's a bit like the HLR and the HSS. That holds information about subscribed slices. And the policy and charging function holds information about slice policy. Okay. So as an example, so this is courtesy of a white paper there, 5G service white paper. So this shows that we've got 3 different devices, and it might be that one device is using an AMF and accessing a session management function and the user plane function for support of enhanced mobile broadband services. So that's a network slice instance. And perhaps another device might be using, in this case, embedded within a vehicle, might be using the same AMF, but the AMF would direct this service, this customer, towards another SMF and therefore another user plane function. And then completely separately, massive machine type communication. So this might be a meter. So perhaps trying to get a meter reading from a electricity meter or something. This could have its own sort of infrastructure, if you like, where the AMF itself is completely separate from the other. So it just gives us a level of flexibility. Now, this is actually quite a simple example, but this just shows that you can have a level of flexibility in the network just to facilitate the different slices and the different service types. Okay, so we want to get into some of the specifics now. So let's look at defining the network function services. So there's a service-based interface. So we've got a network function there. We're not saying what that network function is, but the way in which we define that is that each and every network function will have a number of services available to it, because that's what's defined in the API. And each of those network functions will have a number of operations available as well. So we've been using this convention already. We've got a naming scheme. So capital N, followed by the network function name, followed by the service name, followed by the service operation, followed by the method. So for example, SMF, using the PDU session service, using the service operation create session management context, and the request, or it could be the response to that. So in general, it's going to be a request and response. We could also have a subscribe and notify, but more on that a little bit later. So an example is the AMF. So the AMF there has got a service-based interface here, and it's got two different interfaces here. So they're not service-based at all. So the AMF does pretty much what the MME did in 4G. So it's things like registration, but also sending messages to and from the device and to and from the base station as well. A few other things. And this is it. So release 15, these are the services. 1, 2, 3, 4 services. That's all. Probably the most important is this one. So this is AMF communication service. The operations available are these. So a really important one to see quite often is this, N1, N2 message transfer. So what we're saying is that perhaps the SMF wants to talk to the device and the base station about connectivity. So the SMF can request the service, i.e. the AMF communication service. Specifically, it can request it using the N1, N2 message transfer to say, so the SMF can say to the AMF, hey, can you send this information to the base station and also this other information to the UE, to the device. So a couple of other things going on as well. I won't go into the specifics. I will pick up the event exposure later. Okay, but I do want to look at the protocols. So let's have a look at HTTP2 and the JSON. So first of all, on the service-based interfaces, we use HTTP2, TCP/IP over an appropriate data link and physical layer. There are other protocols being used in the 5G system. So we've got, between the SMF and the user plane function, we've got the packet forwarding control protocol, PFCP, which is something that we actually saw in 4G, later versions of 4G. So that's a whole set of protocols within that stack in its own right. Also, we've got the non-access stratum stuff here, which is carried over a variety of different transport mechanisms, which again, we're not going to go into, but where we want to focus is this. So there you go, that's the stack. So the various service-based interfaces operate at this level. So it's an open API. It's available, they are in the standards. So the standard format for carrying the SBI service-based interface messages is JavaScript object notation. Oh, Shakil, great question. So our network slicing required do they require dedicated resources or use shared resources from the core or RAN? So that's the whole point about virtualization. It can take whatever form, whatever deployment option the operator sees fit for that particular customer, for that particular slice, for that particular request. So the whole decision-making process of management and orchestration, that's separate to what the service-based interface brings. But once we made the decision about whether they are shared resources or whether, this is a service which is required to be provided in a highly secure way for perhaps the security services, that would be dedicated. So you've got a level of isolation there. Perhaps if it's anything consumer, in the main, they're going to be provided on shared resources. Perhaps if it's going to be perhaps if it's going to be content, Netflix, then you try and offload that from the core network. So it depends on the service. But what we're saying is that the service-based architecture gives us the flexibility to do whatever is optimal as an operator. Yeah, so everything's moving towards virtualization programmability. In general, yes, a massive in general there. So in general, yes, we are moving towards this world of virtualization in general. Right, so back to this then. So the JavaScript object notation is just a standard way of carrying this information. The actual end-to-end request response mechanism is provided by HTTP2. That takes the form of, or takes the functionality of what we had with TCAP way back when in the SS7 heyday. Sorry, excuse me. Then we've got TCP. We haven't got anything next to that because it's not adding anything massively extra to what we've got with HTTP2, except a lot of systems are based on TCP. Hence, it'll just make, I guess, deployment possibly slightly easier in some instances. Transport layer security, that protects the messages traveling between the functional nodes if it's implemented. So Yusuf just asking, as per your experience, the operator of vendors ready for this move, or they must be ready soon? So a lot of operators have started the move towards virtualization, absolutely. A lot of operators are well on the road and they've done it quite well in terms of the actual network function virtualization prior to 5G. They've been struggling with management and orchestration, which for a lot of operators is still a fairly manual process. With 5G, the actual virtualization itself, I think, becomes easier, but not many operators have actually got the 5G core in place yet. So they haven't got this service-based interface in place. They haven't made it easier for themselves yet because there's a timeline as 5G is deployed, if that makes sense. And we're not yet at that point for most operators. So they've got a lot of virtualization in place. So the infrastructure is, more ready than it would have been if we hadn't done that. But only a few have actually started popping in the 5G service-based architecture. Not a very satisfactory answer, Yusuf, just because we're just on the cusp now. Different operators will be in different places with this. Okay, so let's so just make a point that TCP here has been used in release 15 to 17 of the specification. So I've checked that recently. There is talk, and it may well use to UDP quick in the future, which is just it's something which we're seeing more and more in these sort of systems, but not yet supporting the service-based architecture, but there is talk of that. So why are we using HTTP2, not HTTP1? Well, because HTTP1 had, it is really good for what it did. It sort of allows us to manage those end-to-end connections, but it's a single association, which means you can see it as a single pipe. So if you want lots of things going on between two two endpoints. There's a problem with one of those interactions. You end up with sort of head of line blocking, so long latency. And it's pretty inefficient as well because we use text, and machines don't need text to operate. So in HTTP2, we get rid of the text, we just use code, binary. And we introduce a new layer. So we can end up with a number of streams within the same connection. So if you've got blocking on one of your streams because it's not getting the responses that we need, you don't get the head of line blocking. So it's more efficient. You don't get the head of line blocking, and we can have optional waiting or priorities for the streams as well. So it's a more suitable system, HTTP2, more suitable protocol than ever HTTP1 was. But it uses sort of standard HTTP methods. So we've got the get, put, patch, delete, post. Now you probably remember from when you first, if you did sort of IT at college or university, you're probably talking about CRUD systems, which is really a term from the 1980s, but create, read, update, delete. They're sort of standard database type systems. And that's what HTTP has been designed to provide. So create will be your put, read will be your get, update will be your patch, and delete will be your delete. And then, of course, it's never that simple. So with HTTP and HTTP2, we've also got a post, which for our purposes in 5G means that we can sort of look at custom operations as well. But there are some things in HTTP that we haven't used in 5G. So head, connect, options, and trace, we don't need those. So we just concern ourselves with these. So they're just sort of standard methods, if you like. We use the term method, but that's what you see when you exchange information between two endpoints using HTTP2. It is a request response system. So the responses that we normally get, we've seen these previously. If you worked on session initiation protocol, or even if you just, browse the internet, you'll have seen 404 not found. These are standard HTTP response codes, but these are the ones, if you're interested, these are the ones that we use and we've adopted in 5G. So not the entire set, but these are the ones that are available to us in 5G. And the headers, so what type of information can we carry? Well, it depends whether it's in the request or the response. Again, if you're interested, if you need this level of detail, this is what we've adopted at least at release 15 of 5G. So different data, different information types. Now the actual, do you remember the message? Do you remember that update location that I explained right at the start of the presentation? I did say that we were going to code that up using JavaScript object notation. So here you go. JSON, HTTP could carry a JPEG picture. It could carry any number of different things. But in 5G, we're using it to carry this stuff, JavaScript object notation, which is just a way of representing information. That's all it is. So we can carry images, we can carry thumbnails, we can carry array of numbers. You can carry Boolean, true or false. It's just a way of formatting information. That's all JavaScript object notation is. So again, just to go back. So back to this. We've got the information, whatever it is, the update location with all the parameters, which will be formatted using JavaScript object notation, which would then be carried end to end using HTTP2, hopefully in a secure way. Okay, so just two things left then, just to sort of start bringing it all together, and then just a couple of words on the security. So bringing it all together, let's have a look at network function service registration. We saw this diagram earlier, we saw this part earlier. So we know that from a service-based interface point of view, we can just keep it really simple and say, okay, we know that the registering network function, whether it's an AMF or SMF or whatever, is asking the NRF to use its network function management service. And specifically, we're using a network function register operation, and it's a request. And this network function is simply telling the NRF all about itself. So I'm an AMF. I'm supporting these slices. Here's my unique ID. Here's my IP address. Here's my capacity. And we know that the NRF will come back and echo that back together with a heartbeat time. And also we update that occasionally. Now, what that actually looks like in terms of the HTTP message is this. So there you go, HTTP put, and it's been sent to this set of information here. So HTTP or HTTPS, we then go into the API route. So in this case, it's network repository function dot 5G core, 5GC, dot mobile network code, MNC, dot mobile country code, dot 3GPP network.org, or as decided by the network operator. So hopefully you're starting to see how it's all coming together now. You can see how HTTP gives us the actual reference. The API name, the specific API name, so the service is network repository function, network function management. That's the API name. That's what comes next. Version, they're all at version 1. Network function instance ID, universally unique ID. And then the parameters are coded up using JavaScript object notation. And the response will be a HTTP, in this case 201, created response, together with JSON response. Now, the only time that this wouldn't be coded up using JSON is when it's a HTTP GET. So if it's a GET method, then all of this would have to be in the URI, just because of the way HTTP works. So there, I won't go through this in detail, but that's a network function service discovery. But it's the same sort of thing. So that's what we look at in terms of the actual service-based interface, and this is what it looks like when we map that to HTTP. So the API route, as before, as I taught you through earlier, the NRF discovery service this time. All of that would, well, this time it's a GET, so they would have to be included as query parameters. So as part of the URI, because it's a GET. But apart from that, it's the same sort of principle. So if you wanted to look at this in terms of a procedure, so this is a PDU session establishment procedure. So green and orange are not service-based interface interactions. These are others. So this is the packet forwarding control protocol. This is the non-access stratum session management and mobility management messaging. But you can see how the AMF can send information to the SMF. Once it's talked to the NRF and it knows which NRF it's, sorry, which SMF it's using. So that would have happened previously. So the AMF will have the SMF identity ready to go here, and it will send a message to the SMF asking the SMF to use its PDU, packet data unit session service, using the create session management context operation, and it's a request. And there will be a response to that down here, but the SMF will know that once it gets that request, it kicks off lots of interactions with the UDM using the UDM services. You can see there. So all of the stuff inside the red boxes there are service-based interface interactions. And in fact, this is a long procedure. It goes on. So there's another slide there just to show those procedures. There is just one additional thing in terms of procedures, which is that at any time, any network function can ask the other network function for access to a service, and it will get a response. But as part of the interaction, it might also come back and say, okay, what I really want to do is I want to know if there's any updates. So, if anything changes, if Tony changes his subscription details, or if somebody, disconnects, let me know. So any network function can ask any other network function for updates. So we can subscribe for updates and we can be notified of any updates. That's all this slide is saying. All right, so just if everybody's, I know we're on 90 minutes, but if you've got another 3 or 4 minutes, we should be able to crack the last bit. So security and the service-based architecture. So the first thing is, what are the principles? So there's a reference down at the bottom of the slide there. But the principles are that all network functions need to support transport layer security. There is a profile given in Annex E of TS 33.310, but it's got to be compliant with a profile given in by HTTP2 as defined in RFC 7540. So for the security nerds or those who need to know this stuff, there's your reference. It also states that transport layer security shall be used for transport protection within the public land mobile network unless network security is provided by other means. So it gives the operator some flexibility, but on that service-based interface, we need to have TLS available to us. Oh, Prabhat, you just asked what happens if we don't get the heartbeat and everything falls down. It'll probably be the same sort of indications that we get at the moment. If we look at the actions, if we miss a heartbeat time, that'll be set out in the standards as to what the next action should be. But if the connectivity is lost, then the customer will just see the same sort of indications or experience the same thing as we saw in 4G. I don't think it's going to affect the end customer to any massive degree. It's just the way in which the sort of core network operates. So yeah, things will disconnect, and that will eventually cause a disconnection for the customer. But I don't think they're going to notice anything too different, to be honest. Okay. So lots of details there, lots of references, but I do want to get to this point, which is the security edge protection proxy. So whether I'm in Dubai trying to access something back in the home network, so perhaps trying to access the internet or some server, or whether I'm in Dubai trying to access something local, the Etisalat and the UK operator need to talk to each other in both cases. So they'll do it via the security edge protection proxy, SEP. And the SEP acts as a non-transparent proxy. It protects application layer control plane messages. It allows the two operators to mutually authenticate. It sets up the cryptographic keys, provides topology hiding as well. So the UK operator can hide the topology from any requesting operator. Provides that single point of access into the network. It verifies the sending SEP, differentiates certificates used for authentication of PSEPs, discards malformed messages, implements rate limiting, and implements anti-spoofing. So the SEP, Security Edge Protection Proxy, which itself has got its service-based interface, is an absolutely key part of this. Now, the problem is that between Dubai and the UK, you may well have some IPXs, some IP exchanges. So in this case, the provider and consumer, we use the term provider and consumer IPX, just as a standard naming convention as in terms of server, client server type architecture. We use producer and consumer. So what's happened here is that we want to get a message from over here to over here. So the whole thing will arrive at the consumer SEP, and we don't want to provide security and encryption across the entire message. So what we do is you just take the relevant bits of the JavaScript object notation and we just secure those. Then that allows the IPX, if it's providing services, routing services perhaps, for this particular network operator here, it allows the IPX to work on the message, to alter the message, so long as it signs using JavaScript, JSON web signatures, as long as it signs for the changes that it's made. Eventually, the whole thing will arrive at the provider SEP here. We look at the incoming message, we de-encrypt the bits that were encrypted, we authenticate the web signatures, we put it all back together again, and we send it on its way. Now, what this practically means, if you're not into security, all it means is that here we've applied something called application layer security instead of transport layer security. So we just selectively encrypted things like location information, identity information, encryption information, together with anything else that the two operators agree to encrypt. So it's just more flexible. It means that the IP exchanges can be involved still, providing us with certain services, rather than just making sure we've just got an end-to-end tunnel. We still do need an end-to-end tunnel, a TLS tunnel anyway, for these two to talk to each other. But when we've got their functions talking to each other, they can go via the ALS system instead of TLS. Okay, sorry, I overran slightly, but hopefully you'll forgive me for that. Just a big reminder really of why we're doing this. So what we were trying to do is get you guys ready really to make the most of FutureNet, because there's going to be lots of talk of obviously virtualization, but specifically within the mobile world, which is different to the fixed world. There are quite a few differences, and it's at the service-based architecture level that the differences really occur. So we were just trying to get you up to speed, prepare you a little bit, perhaps arm you with some questions for when you arrive at FutureNet Asia on the 27th. So I'm hoping that we achieved that. So just a last question from me then. Did you find it useful? Right, can I suggest concepts for what I've explained? Well, I mean, first of all, our training courses, of course, and if I just go back to, sorry, just bear with me a second. Yeah, if I just go back to this slide, you can see there's a discount code there if you want to use that. 15% off any of our training courses. So, I mean, that's a good resource, simply because we've had to make sense of this, because we train most of the, certainly most of the UK-based operators, but also many others as well. But secondly, there are one or two books. So there's a very good book by Chris Cox. I just need to check whether Chris actually deals with the service-based architecture. He does, but a lot of it is also radio-based. But I think the best thing to do is just send me a quick email. So if you're interested in resources, send me a quick email. There's my email address there, twakefield@raycastle.com. So send me a quick email and I'll try and get a reference for you. So good. So did you find it useful? I think that's the last thing I normally ask. Good. We covered a lot. I'm hoping that it made sense. We always try and get a story in place. Hopefully we did that. Good luck with the FutureNet. Hope it goes well, and stay in touch. If you want to connect on LinkedIn, look me up. If not, hopefully see you again on some future session. Paul, I don't know if you wanted to jump in and say anything at the end there.
No, thanks, Tony. Just to thank you for the session, and just to let everyone know that I'll send a copy of the recording of the session out within the next couple of days. So look out for that.
Thank you very much. Thank you, Tony. Thanks.
Thanks, everybody. All right, take care.
Thanks.
Bye-bye.